Hello everyone, welcome back to the newest devlog where I'm going to try and redo this intro because the original one was incredibly boring. So today I just want to give you a quick overview of what the plan is. I want to rework the pushing and pulling system, the mechanics by which the player will be using to navigate the map in a sense, where you essentially anchor yourself to a point that you're pointing at and then you will pull yourself towards it very quickly. And so all of this starts, for me at least, my workflow starts in the animations, which was a good learning process for me getting back into it. I had to reinstall the Mr. Mannequin's Tools Blender add-on, which was something I'd forgotten about since updating Blender and ditching this project a few months ago. So highly recommend that that add-on for Blender because it's very good for importing the Unreal Engine 5 skeletons and creating work based off of that. I'm not going to go into the specifics of how to actually animate and get a good workflow going. I would say if you want that, go check out Prismatica Dev. He has some great tutorials on the subject, especially his first walk cycle one. So yeah, go check that out, and let's wrap up these animations and get them into Unreal Engine. Oh, you know what I didn't create is the actual hold animation. Alright, a bit of tinkering around and I got my hold loop. So now what I want to do is I want to go to the animation graph and make sure that these things are properly set up to function. Okay, so we faced a few setbacks, but I think I've got it in a place that I like quite a lot. So let me walk you through what I had to do. In this Mistborn graph overlay state here, sorry, the animation Mistborn graph, I was looking at the wrong file before when I was talking about it, but here we have the original coin draw, idle, and put away, and then the actual throwing was a montage. So we don't have that in here. However, here we have a coin attach, throw, and loop for this new version. It's essentially a new idle where we copy and paste the values in this overlay state, and then we add our own animation here. So this is the actual putting the arm out animation, and we needed to add these three curves here for layering arm L, layering spine, and layering hand left, and that we set these values with keyframes to 1, and that allows the ALS animation system to actually apply this layer of animation on top. So we did that, and then we also made this new method called throw coin event, which gets the camera location, the camera forward vector. It then multiplies the forward vector by coin throw range, which is a value I define up here, 3000 vector in each direction. We add the two together, so camera locations are start, and then the vector multiplied added with camera start location is our end. And this hit, if it hits, we enable this coin attach state right here. Let me delete that. This coin attach state, which, if we go back to the animation graph, is the condition for entering this throw animation. And so all of that together, what it gives us is an ability to aim and throw, and then we have our hand reaching out here. Now I would like to have the hand go down when we leave aiming mode, and then I would also like to have the hand track this location. So the plan now is to spawn an item at this hit node right here on this wall, preferably to place a coin there so you can actually visually see where the coin was shot into, and then if possible track the hand or the arm to that location and see how nice I can get that looking. If it looks too bad, we can change it, but that is the plan, so let's get to it. Hello everyone, it's been about 2 days and I've been working on this on and off, and I want to give you an update as to where I am currently. So what I've done since then is I created 4 additive animations for the coin hold which they are four modifiers that I've, or I guess, four modifiers that I've put into a blend space, which we can see here, which now lets us change the direction of the arm. I figured this would be much easier and would look better than to actually just move the arm bone depending on where it is. So this is looking good. Now all I need to work on is the implementation here, which we actually have the base animation, the hold loop here, with an apply additive of our blend space, which I just showed you. But we don't have any values plugged in yet, and I'll show you why. This is the new method I made, tick arm aligner, which has our impact point, and then what we go ahead and do is we get the forward vector of our player capsule, and then we get a vector between our player capsule and the impact point, so we just subtract the vectors here. And then what we do is we go ahead and do a the formula to get the angle between two vectors, which is r cosine of the dot product of two vectors over the magnitudes multiplied together. So that's what all this math is. And in order to do it in 3D space, what we had to do we had to do this twice, once on the XY axis and once on the XZ axis, and that gives us our two values, XY and XZ, which the idea is XY is moving the arm left and right, and XZ is moving the arm up and down. So the issue I have currently, which I'm working to resolve, is that whenever we cast this forward, you see this value on the left, 11, it moves up to 42, and I believe it goes up to a max of 90, or I guess just, you know, up to whatever angle it is, which is good because we're gonna use this value to move the arm. But if you notice, as I turn here, there's no actual indicator as to whether or not it is left or right from the player capsule. There's no negative value, it's all absolute. So this is positive 90 from this point right here, this is positive 90, and this is also positive 90. And if we go ahead and print the XY value as well, or sorry, XZ value, the up and down, our hand would be pointing more and more up right here, and then if we got up somewhere like right here, it would be pointing more and more down as we get closer. And again, same here. There's no negative indicator. They're all positive. So that's what I'll be working on next, is figuring out how to create this up, down, and left and right modifier based on vectors. So yeah. Ow, dude. That looks like it hurts. Alright, well, I don't think your hand is supposed to look like that. You know, in Finding Nemo, when that starfish peels off the edge of the fish tank? That's what his hand looks like right now. It's disgusting. It was actually quite an easy fix. All we had to do was change the additive animation from mesh space to local space. So, simple mistake, but we got it. Alright, so I've been tinkering around with it, and we got it actually to a pretty good state, I mean, not spot, whatever. What I ended up doing to fix this issue right here is all I did was go ahead and add 60 to the Z value of the player capsule to basically account from the distance of this middle of the capsule up to the player's shoulder, and that seems to work pretty fine. And then there was another issue where if we were changing the axis in which we were facing, so if we did for instance the y-axis and then we changed to the left axis, it would just default to 1 or -1, which it looks like it's doing, although I think I'm printing the wrong thing. Yeah, I'm printing the XY, so it's not actually the problem. What would happen essentially is if you did a 90-degree angle, specifically on this axis, the arm would just go straight up or straight down. And so the fix to that was to take the two vectors that we use to calculate the angle between them on the z-axis and actually give them the same x value. Before I was just giving it the straight x value of the impact point and the player location. But for this, what I ended up doing was I just took the vector from the player to the impact point. I did a Pythagorean theorem, square root of the squares added together, and I set both of these x values to that. So essentially what we get, if I open up Paint, is we have two vectors of equal length. The only thing different is the z value. So I guess it's not of equal length. Technically this one's longer, but it'll give us the true angle no matter what direction we're facing, because they're, no matter what, going to be on the same plane and of the same length. So we'll get the pure up and down angle, and that seems to work quite nicely. So I think I'm going to end the video here, and then the next one I will go ahead and try and implement the montage of the player pulling themselves towards the point. So thanks for watching, and I'll see you in the next one.